Hello learner, welcome to Manifested e-learning classes. My name is James Kenyani. We are going to proceed with our solutions on question on this topic, measurement 1. So there is an assignment which I gave to you in the last lesson. We are going to see how you are supposed to get the solutions. So we go straight to question number 1. Question number 1 looks very short, but very important. It is testing you on your capability of knowing the relationship between units. Question 1. A drug manufacturer gives the mass of an active ingredient. Active in the sense that that particular part is the one that treats the disease. Gives it in a tablet as 5 milligrams. Express the quantity in kilogram and give it in standard form. So we go to the solution. So before you start, you should know 1 kilogram is equals to 1,000 grams, and 1 gram is equals to 1,000 milligrams. So from the two statements, it will go with therefore 1 kilogram will be equal to 1 million milligrams. 1 million milligrams, and vice versa. 1 milligram is equal to, you divide, you'll get 0.00000 1, 2, 3, 4, 5, 1 kilograms. So when you are given milligrams, you'll be forced to change into kilograms. So 5 milligrams is equal to 5 times 0.00000 1, 2, 3, 4, 5, 6 kilograms. In fact, that is the answer, but you are supposed to give it in standard form. So that will be 5 times 10 power negative 6, isn't it? 10 power negative 6 kilograms. That is the in standard form. So that gives you the answer. It was testing you on knowing the relationship between a kilogram and a milligram. That is the solution for that question. Question number 2. It is something very practical, and before you go to solving that, it is testing you to know that when you fill a glass with sand, the sand doesn't completely fill that glass in volume because there are spaces in between the sand particles. There are spaces that remain between the sand particles. So in an experiment, the density of sand, to determine the density of sand using a density bottle, the following were recorded. The mass of the empty bottle was given as 43.2 grams. Mass of the density bottle with water was given as 66.4 grams. Mass of the density bottle with sand was given as 67.5 grams. Mass of the density bottle filled with sand and water, 82.3. Just what I was saying, it has sand, but when you fill water, the water takes up the interparticle, the spaces between the particles. It came to 83.2.3. So it is true to say that when you filled that bottle with sand, that was not the true volume of the sand, because there were some spaces that were remaining in between the particles. So we go to a solution. Solution step by step. You are told mass of the water that filled the bottle. Mass of the water that filled the bottle. You come here. Mass of the water will be given by mass of the density with the bottle subtract mass of the empty bottle. So mass of water. So it will be given by the mass of the bottle filled with water subtract the mass of the empty bottle. So this will be 66.4 grams subtract 43.2 grams. That gave us, from that it gave us 23.2 grams. That is the solution to the first question. We shall go to the second question. Having done with this solution for one, let's use this space. B, volume of water that filled the bottle. You know, volume is equal to mass divided by density. I said always, if you are not given, always take the density of water to be 1 gram per centimeter cubed. Always take the density of water to be 1 gram per centimeters cubed. Therefore, volume of water will be given by that 23.2 grams over 1 gram per centimeter cubed. That will still give you 23.2 centimeters cubed. That will be the volume of the water. That will be the volume of the water. You come to 2, volume of the density bottle. So you have to know that volume of the density bottle will be equal to the volume that filled the density bottle. But you already know that volume. So volume of bottle will be equal to the volume that filled volume of water that filled it. This is given as 23.2 centimeters cubed. That will still be the volume of the density bottle. And then You are told the mass of the sand. Mass of the sand. D. Mass of the sand will be given by mass of the bottle filled with the sand, subtract mass of the empty bottle. And I think that is given there. When it is filled with the sand, it is 82.3 grams. So this will give us 82.3 grams, subtract 43.2. 43.2 grams. That worked up well. It gave us 24.3. Is it? No, this was supposed to be 67. 67.5. When it is filled with sand, it is 67.5 grams. So when you subtract, you'll get 24.3. 24. You'll get 24.3 grams. That is the mass of the sand. So we go to the next question. Mass of the water that filled the space above the sand. That is what I was talking about. It is when you have filled the sand in, then you add that water to fill up the interparticle spaces. So that is what they are asking for. When you fill the glass with sand, we have spaces between the sand particles. So they are asking for that mass of water. So we go straight to that solution. They're asking for the mass of water that filled the space above the sand. So that will simply be, you'll go to these. It will be the mass of the bottle with sand and water. Subtract mass of the bottle with sand only. So, and those are given. We had been given, although it was here, in that solution, we are given these 82.3 grams, subtract 67.5 grams. That gave us 14.8 grams. So there is something you should note. What we are getting here is actually the volume between the particles of sand. What we got earlier was not the exact volume of that sand. That's why the question comes, volume of sand. You should actually be very keen here. Volume of the sand will be equal to the volume of the bottle subtract volume of water that filled the space above the sand. So the volume of the bottle, we had earlier calculated it as 23.2 grams. Then we subtract 14.8. 14.8. We get 8.4. These are centimeters cubed, sorry. These are centimeters cubed volume. This is volume. So there is a concept that has been built there. The volume we initially got was not the exact volume because there were spaces in between the sand particles. So they come and we have now got the exact volume of the sand. That's why they ask for the density of sand in the last question. Density of sand will be equal to the mass of the sand over the volume of sand. Mass of the sand, I think we calculated it somewhere. Mass of the sand, it was 24.3. We divide by the volume, which we've got as 8.4 cubic centimeters. So that will give us 2.893 grams per centimeters cubed. So that it is in a setup of an experiment to determine the exact density of sand, and you can do it on your own when you have a spring balance to get the exact volume of sand. In that case, you can not only have the density but low, you can have something with fixed capacity to determine that. So with that, you'll get questions for the assignment. So those are the questions. We'll go through the questions. Question 1. A room has a rectangular floor of size 400 millimeters by 3,600 millimeters according to the architecture plan. The floor is fitted with square tiles of side 12 centimeters. How many tiles will fit on that floor? Therefore, in question 2, a cylindrical metal bar of diameter 14 centimeters and length 484 centimeters is to be melted into metal cubes of side 220 millimeters. How many cubes will be produced? And lastly, two immiscible liquids, immiscible, they don't mix. Two immiscible liquids, A and B, were mixed together in a container. Liquid A weighs 7 newtons in a 1 liter container. B weighs 10 newtons in the same container. Which liquid will float on the other? Which liquid will float on the other? So those are the questions for the assignment. So I hope you've enjoyed through the solutions. As we work through the solutions, so go and work out those, and let's meet in the next lesson as we go through those solutions. Thank you very much, and let's meet in the next lesson. Bye-bye.